Hello and welcome to CET 4884 Security Methods and Practice. In this session, we will continue our discussion on firewalls through understanding their architecture. In addition, we will learn how to select the proper firewall, configure it, and manage it. Each of the firewall devices noted in the previous session can be configured in a number of network connection architectures. The firewall configuration that works best for a particular organization depends on three factors: the objectives of the network, the organization's ability to develop and implement the architectures, and the budget available for the function. Although literally hundreds of variations exist, there are four common architectural implementations of firewalls: the packet filtering routers, screened host firewalls, dual-homed firewalls, and screened subnet firewalls. Most organizations with an internet connection have a router as the interface of the internet or to the internet at the parameter. Many of these routers can be configured to reject packets that the organization does not allow into the network. The drawbacks to this type of system include a lack of auditing and strong authentication, and the complexity of the access control lists used to filter the packets can grow and degrade network performance. This figure shows an example of packet filtering router, and as we can see here, we have the internal trusted network, and this is the untrusted network from the outside, and any untrusted data packet that will come will be blocked and rejected through the packet filtering router that connects the untrusted with the trusted network. The one that will be filtered and approved will go through and get into the trusted network. This architecture combines the packet filtering router with a separate dedicated firewall, such as an application proxy server, allowing the router to pre-screen packets to minimize the network traffic and load on the internal proxy server, and this is the screened host firewalls. So the application proxy examines an application layer protocol and performs the proxy services. This separate host is often referred to as the bastion host or sacrificial host. It can be a rich target for external attacks and should be very thoroughly secured. You are sacrificing that host because it's the one that will be connected to the external or to the untrusted networks. This figure shows an example of the screened host firewall, and as we can see here, we have the patient host and we have the router. So we have two filtering channels or devices, and those two can assist in blocking the packets and filtering what comes in, and then just getting to the trusted network the packets that will be trusted and will not affect the internal network. The dual-homed host firewalls, with this approach, the bastion host contains two network cards or network interface cards, one connected to the external network and one connected to the internal network, providing an additional layer of protection by requiring all traffic to go through the firewall to move between the internal and the external networks. The implementation of this architecture often makes use of NAT mapping, assigned IP addresses to special range of non-routable internal IP addresses, creating yet another barrier to intrusion from external attackers. And this figure shows the dual home host firewall, and as we can see here, we have the proxy axis or the dual home host that's in the middle, and it has the or it can do network address translation or NAT technology. So it will have two network cards, one connected to the external filtering router and one connected to the internal data packet router, and after that it will pass through the trusted packets only. The dominant architecture used today is the screen subnet firewall, which provides a DMZ which can be a dedicated port on the firewall device, linking a single patient host, or it can be connected to a screened subnet. Common arrangement finds the subnet firewall consisting of two or more internal patient hosts behind a packet filtering router, with each host protecting the trusted network. Connections from the outside or untrusted network are routed through an external filtering router, and connections from the outside or untrusted network are routed into and then out of a routing firewall to the separate network segment known as the DMZ. Connections into the trusted internal network are allowed only from the DMZ bastion host servers. The screen subnet is an entire network segment that performs two functions. It protects the DMZ system and information from outside threats by providing a network of intermediate security, and it protects the internal networks by limiting how external connections can gain access to internal systems. DMZs can also create extranets segments of the DMZ where additional authentication and authorization controls are put into place to provide services that are not available to the general public. The socket secure or SOX is an internet protocol that routes network packets between a client and a server through a proxy server. Socket secured system requires support and management resources more than the traditional firewalls. When selecting the best firewall for an organization, you should consider a number of factors. The most important of these is the extent to which the firewall design provides the desired protection. And this is what we're looking for. We're looking for the proper protection for the company. So we are looking for what type of a firewall technology that offers the right balance between protection and cost for the needs of the organization. And then what features are included in the base price and what features are available at extra cost. Are the cost factors, all the cost factors known? Is it justifiable? Could it be of a benefit more than it will harm? And this is what we look for when we analyze for the cost. And then how easy is it to set up and configure the firewall? How accessible are the staff technicians who can configure the firewall without any problem? And can the candidate firewall adapt to the growing network in the target organization? The second most important issue, of course, is the cost. Configuring and managing the firewalls. Good policy and practice dedicates that each firewall device, whether a filtering router, patient host, or other firewall implementation, must have its own set of configuration rules that regulates its actions. The configuration of firewall policies can be complex and difficult, and configuring firewall policies is as much an art as a science. Each configuration rule must be carefully crafted, debugged, tested, and sorted. When configuring firewalls, keep one thing in mind. When security rules conflict with the performance of the business, of course, security often loses. We are looking for better performance more than we are looking for security. So, of course, it's going to be losing against the performance of the business. Looking at the best practices for firewalls, all traffic from the trusted network is allowed out. The firewall device is never directly accessible from the public network to prevent any intruders from changing the firewall's policies, and by doing this, then intruders will be able to get in the network. Also, it's very important to look at simple mail transport protocol data, which is allowed to pass through the firewall, but should be routed to a well-configured SMTP gateway to filter and route messaging traffic securely. Any untrusted email message will be sent to junk mail, and make sure that it is disposed of. All Internet Control Access Protocols data should be denied, and telnet access to all internal servers from the public networks should be blocked. When web services are offered outside the firewall, HTTP traffic should be denied from reaching your internal networks through the use of some form of a proxy access or DMZ architecture. Firewalls operate by examining a data packet and performing a comparison with some predetermined logical rules. This logical set is most commonly referred to as firewall rules, rule base, or firewall logic. Most firewalls use packet header information to determine whether a specific packet should be allowed to pass through or should be dropped. This figure shows an example of a good network configuration, and as we can see here, we can see the area of the DMZ zone here, which has the web server, the proxy server, and the SMTP server, which is the mail server. And then we have the external router for packet filtering and the internal router for packet filtering, and we have switch in the middle that connects the external with the internal. And by doing this, we are isolating all untrusted network communication from the internal trusted network to make sure that we are disabling any addresses, any IP addresses that might be attacking the system, and we are filtering all the packets that's coming. The table in this slide shows firewall common known port numbers and their use, and some of them actually well known. You can see them everywhere. For the file transfer protocol, usually it's number 20 or 21. For the telnet, it's 23. For the simple mail transfer protocol or SMTP, it's 25. Domain name services, 53. The hypertext transfer protocol with the HTTP is 80. Post Office Protocol version 3 POP3 is 110, and the Simple Network Management Protocol or SNMP is 161. The table on this slide shows a recommended rule set for external filtering firewall inbound interface. Note that the rule allowing responses to internal communications comes first, followed by the 4 rules prohibiting direct communications to or from the firewall. After this comes the rule stating that all outgoing internal communications are allowed, followed by the rules governing access to the SMTP server and denial of ping, telnet access, and access to the HTTP server. If heavy traffic to the HTTP server is expected, move the HTTP server rule closer to the top, for example, into the position of rule number 2, which would expedite rule processing for external communication. And the final rule in the table denies any other types of communication. The table on this slide shows recommended rule set for external filtering firewall outbound interface. So that was inbound, this is outbound interface. Note the similarities and differences in the two rule sets. The internal filtering router firewall rule set shown in outbound has to both protect against traffic and allow traffic from the internal network 192.168.2.0. Most of the rules in this table are similar to those in table 616, allowing responses to internal communications. Rule number 1, denying communication to from the firewall itself. Rule number 2 through 5, and allowing all outbound internal traffic. That's rule number 6. Note that there is no permissible traffic from the DMZ systems except as in rule number 1. Why isn't there a comparable rule for the 192.168.2.1 subnet? Because this is an unroutable unroutable network. It's external communication that are handled by the NAT server, which maps internal 192.168.2.0 address to external 10.10.10.0 addresses. This prevents a hacker from compromising one of the internal boxes and accessing the internal network with it. The exception is the proxy server, which is rule number 7 in table 617 here, which should be very carefully configured if the organization does not need the proxy server, as in cases where all externally accessible services are provided from the machines in the DMZ, then rule number 7 is not needed. Note that there are no ping and telnet rules in table 617. This is because the external firewall filters these external requests out. The last rule, which is rule number 8, provides cleanup. That will be all for this session, and we will continue with the firewalls and talking about the remote access and VPNs in the next session. So that will be all for this session. Thank you and have a great day.